Yeah, good morning, everybody. And we are going to start our program shortly. So please take the seat. Thank you. Good morning, ladies and gentlemen. And then let's start our program here today. And this is a plenary discussion in tribute to Dr. Po-Tai Cheng. And before we start our plenary discussion, I would like to basically create some record here and then tribute to Dr. Po-Tai Cheng. And I would also like to invite two other plenary organizer or we call it the MC here, that to be on the stage. So Dr. Knight, come on. And Dr. Professor Huang, that basically one that from IAS side, and then the other one is a local committee. So yeah. To introduce yourself.
Hi everybody, my name is Andy Knight. I'm past president of Industry Applications Society and professor at the University of Calgary.
I'm Stephen Shijie Huang. I'm from National Cheng University, Tainan City. Thank you very much. Okay, thank you.
Okay. So, yeah, let's start with basically, as I have mentioned, that with the deepest respect, okay, and heartfelt gratitude, then this plenary session is attributed to Dr. Po-Tai Cheng. His dedication and the contribution to the IEEE Industry Application Society have left a lasting impact on our community. Our thoughts are with him during this challenging time, and we earnestly wish him healing and a full recovery. So we're going to play video and with some past officer and his colleague to basically recall his contribution.
Hi Po-Tai, how are you my friend? I miss you very much. It has been an honor and privilege to know you, Po-Tai. We have been friends for over 20 years and it has been an exceptional journey to have you as a friend and also a colleague in various roles within the IEEE and IAS. I have seen firsthand your exemplary and exceptional contributions to IAS as a volunteer in various roles, and also your great technical accomplishments and evolving into one of the world-class experts in various areas of power electronics. I am very happy that we are having this meeting in your home country and to get the chance to meet your wife and daughter and to acknowledge all your technical contributions and exceptional contributions to IEEE and IAS. Take care, my friend.
Hey Po-Tai, it's Dave. Our thoughts and prayers are with you and your family. You have been a true friend and colleague for many years. You and I first met when you were elected as a member at large on the board of the IEEE Industry Application Society. didn't take you very long to get promoted on the board. You moved up to become the Industrial Power Conversion Systems Department Chair. One of my fondest memories, Po-Tai, working with you was when you led the effort to establish a collaborative agreement between the IAS and the Korean Institute of Power Electronics, KIPE. Thanks to your support, we signed a memorandum of understanding with KIPE. I remember too, Po-Tai, in 2018, when I was past president of the society, I was responsible for nominations and appointments. And we universally decided that we couldn't stand not having Po-Tai Cheng on the board again anymore. So you had rolled off of your position as the ICPT chair, but we put you on the slate as a candidate again to become a member at large on the board. And you successfully ran for that, and in 2018 joined the board again. In 2019 you became the education department chair, and in that same year I actually retired from industry, and I worked together with you as I took on a new role as editor-in-chief of a publication of the IAS, the IEEE Industry Applications magazine. I remember working with you, Po-Tai, when you were the education department chair, and really marveling over the many articles that you wrote in the magazine about the IEEE Resource Center, which was an online learning portal that we had recently launched. And you led the effort to populate that resource center with many webinars and tutorials. So many fond memories, Po-Tai. I know that you, throughout your professional career, have been an exemplary researcher with over 120 publications in the IEEE Explorer portal. But more important, Po-Tai, I consider you a true gentleman and passionate about helping others learn. So we wish you all the best again, and I wish I could be there in Taiwan to be with you and your family.
I have known Po-Tai for many years through our activities in the industry application. We hit it off rather well, partly because of our mutual commonality and culture. I left Taiwan at age 9, and Po-Tai obviously is an outstanding professor and leader in the power electronics world in Taiwan. Funny thing is, we got together, and typical of Chinese people, we talked about let's go get them with Chinese. Sometimes we would invite others to join us. Sometimes it would be his students. And we always had a good time. We always talked of many things, and not just technical, not just about the society, but about the world and how we plan on changing it. And his thoughtfulness and kindness always came through, because every time we met, he would show up with little gifts from Taiwan, knowing that I left Taiwan when I was 9 years old. And little things that would make me think of where I was born. And it's that thoughtfulness that solidified our friendship. He always remembered that the little things. I told him once my dad enjoyed Taiwanese tea, 文山包种茶. And every once in a while, I'll find a package with Po-Tai's name on it, and it would be a little bit of that tea. And it made my heart warm, and it made me feel like I have a link to the place where I was born. So I wish you all a good meeting. I am distraught over missing this opportunity to go visit Po-Tai. I wish the Cheng family the very, very best, and to Po-Tai the very best. And I hope one day I can come back to visit. Thank you.
I met Po-Tai several years ago at that time I just started to be involved in the IAS as the European liaison for the Industrial Power Converters Committee. And at that time, Po-Tai was the chairman, and he was a guidance. He was very kind to people, to other people. Now I am the chair of the Industrial Power Conversion System Department. And Po-Tai chaired this department in 2016 and 17. So in some way I'm just, having an experience that is quite similar to what Po-Tai had in those years. And I think that we all should have the same behavior with other people. I wish to him and his family all the best. I really hope he can hear this message from me and from the other people.
Hello, my good friend Po-Tai. This is Avoki. I hope you still remember the good time we spent together. Back in early 2014, when I was chair of the Industrial Power Conversion System Department, and you were the vice chair. So we used to go everywhere together because you wanted to know how the department is functioning, so you could, when you take over, make sure things are rolling well. And I remember even 1 year after you came on the board, I was in the board of IAS. We used to sit together and even chat about what we're gonna do to make sure that our department shines. And the time we spent in Italy, you know, visiting a couple of cities and some places. I remember with your phone, you put the Google map and we were going in the city and chatting all the time and about, what impressive industry application society and the IAS was. And then during our time came the 50th anniversary of our society. Myself and you, we wrote and co-authored a paper that today is in the history because we went back several years, more than 50 years, to look at how our department and committees were doing, and we wrote even people who were chairing them. I really appreciate time with you. I wish you the best, really. And hopefully you're gonna know that we are in your city. My best wishes to you and your family, and hope to hear the best out of you soon. Thank you.
Even before I served on the IAS board, I heard a lot about Po-Tai's significant contributions. My first real close interaction with him was during a board meeting in Italy, shortly after he had recovered from his first stroke. I was deeply impressed by his dedication and insight in advancing our programs. During the COVID-19 pandemic, I was pleasantly surprised to receive a package from him, 10 closed face masks with filter insert. In a time of isolation and uncertainty, that gesture means so much to me. I was truly touched by his thoughtfulness and care. When I heard about his second stroke, I hoped it would be like the first, that he will recover quickly. Even now, I remain optimistic that he will rejoin the IAS and continue contributing once again.
First met Po-Tai in the late 1990s at the IAS annual meeting. We were both students at the time. Great to see him every IAS annual meeting after that, and was always looking forward to talk to him and see his great smile and cheerful nature. He invited me to go visit him in Taiwan in 2010, and he made the arrangements to see a few universities throughout Taiwan, and I was really appreciative of that effort. And I had been on sabbatical in China, and he asked me how were the food in China, and I said, oh, it's really good, the breakfasts are good. And he asked me if there was anything I missed, and I said, well, I really miss just cereal. I hadn't had any cereal in a while. And then after I got back to China, after about a week later, in the mailbox came a box of cereal from Po-Tai. So that just kind of shows how thoughtful he was, and just a really good person. So Po-Tai, we miss you and your cheerful smile and nature, and still wish you the best.
I'm filled with memories of last time that I was in Taiwan, when you welcomed me to your research lab, introduced me to your colleagues, and let me see your research firsthand. Throughout the time that I've known you, from the early days of ECCE and my involvement with Industrial Power Conversion Systems Department, when you were chair of that department, you demonstrated what it means to be a leader through your involvement on the IAS exec board, your work for the department, for the education department, and as a leader building links between IEEE and local engineering societies throughout Asia. You really are a fantastic person and really show what it means to me to be part of this community. And I just want to say from the bottom of my heart how much it's meant for me to know you and how much you all mean to us, and I wish you the best.
Hi Po-Tai, this is Pericle. I just wanted to say a few words about our relationship. It was because of you who chose me as the secretary of the Power Converter Committee that I entered to be part of the great IAS family, a family that you have served always with passion and with inspiring dedication. We have worked together for many years in IAS, and I have learned a lot from you. You have been, for me and for many other colleagues, a great example to follow for your invaluable activities as a volunteer in the IEEE, for your great work as a scientist, and above all, as a human being. I just want to say thank you, and we all miss you. Take care, my friend.
Yeah, thank you, Po-Tai. And we all have a fond memory with him. And well, we are looking forward to meet him again and rejoin the IAS. So the next, we'd like to invite the IAS President, Ayman, and then to present appreciation prayer for Po-Tai's family.
Good morning, everyone. My name is Ayman Rifai. I currently serve as the president of the Industry Application Society. First of all, I want to say that as a society, we are very honored and happy to be here in Taiwan. The Industry Application Society annual meeting didn't go outside. The last time we were outside North America was 10 years ago. So it's very special to be here in Taiwan. And to make this even more special, that we are starting with this plenary session dedicated to Po-Tai. As you can tell from all of us talking in this video, how special of a person he is, exceptional individual. I didn't mention in the video, but we have been friends for over 20 years, and we had the WEMPIC connection. Both of us graduated from the University of Wisconsin-Madison. I think he graduated 1 year before I joined, but because of his exceptional personality, we always felt like family. I mean, whenever we meet, he was a very sincere and warm person. So we are very happy to be in his home country and to recognize him. And what makes this even more special, that we have Aaron and Ingrid, his wife and daughter, attending. So I invite them to come to stage. And we are going to present them with a plaque. This is from the entire family of the Industry Application Society and the Executive Board to acknowledge all of Po-Tai's contribution, and more than anything, being an exceptional friend and a human being. Erin, please make sure to pass this to Po-Tai, pass our best regards. And it's up to you. If you want to say a few words, you are more than welcome to do that. So we can hold it for you.
Okay. Thank you. Thank you, Professor Ahmed and Professor Knight and Professor Ola, IAS Society Professor and Friendship. We appreciate very much all the friendship from this society. And this is also our first experience to come to the conference that Po-Tai went to in the past. So after his joke, we received many warm email from local friend, international friend, students. So we feel very blessed. And Po-Tai now live with us. And even as a patient, he is still very gentle and peaceful. So we also hope that one day he can come here again to join this warm society. And we do want to speak something. And Ingrid now is a freshman also in Tsinghua University. And his interest, maybe the first interest is renewable energy. So perhaps in the future, she will join this big society. Anyway, thank you very much. And I hope you have a successful conference. And because we have other schedule today, so we will leave earlier. Thank you very much.
Thank you. We will give you a box for you. Okay. Yeah, thank you very much, Erin and Ingrid. And I'll pass it on to the plenary session co-chairs. We have a number of exciting presentations. So,
yes, I will ask that Professor Huang to introduce our first plenary speaker.
Thank you very much. Our first speaker is Dr. Cheng, Dr. Jun Yao Cheng. Dr. Cheng Yao Cheng received his master's degree and a PhD degree in computer science from the University of Illinois and Champaign. Since June 2021, he has been with Inventec Corporation as a Vice President of Business Development for developing vision, strategy, and emerging business development. Before that, he was also Associate Vice President at Quantum Cloud Technology for creating a hyper-converged cloud solution. Before that, he was also Senior R&D Director for Cloud System Software Institute for Information Industry. Before that, he was also Senior Manager at IBM Time Watson Research Center, responsible for identifying and creating emerging solutions. Dr. Cheng is also a co-editor-in-chief of the International Journal of Service-Oriented Computing and Applications. He's also served as editorial board of the IEEE CS on electronic commerce. Dr. Cheng co-founded the IEEE International Conference on E-Commerce Technology in 1998 and E-Business Engineering in 2004. He has served as General Chair and Program Chair for over 35 international conferences. He has authored or co-authored for over 200 journal papers and the conference proceedings. He has 12 US patents issued. Let's welcome Dr. Cheng for the presentation. Thank you very much.
Good morning. My name is Cheng Yao Cheng. Just listen to the Po-Tai's honorary is quite impressive. You know, in people's life is rarely have people, all the nice people saying all the nice thing to you. And I think, joke aside, I think that's really remarkable. I graduated from University of Illinois, Urbana-Champaign. It's about a short distance. Well, it's quite some distance, further from the Taiwan Island distance. But it's not far from where I studied for my PhD. The other interesting thing is I was invited my good friend to say give a plenary in Taiwan, in Taipei. Actually, this is New Taipei. For those of you who know, there's a Taipei and there's a New Taipei. So New Taipei is outside Taipei, but it's the northern part of Taiwan. It's a place where I grew up. I spent a long time in US. About 10 years ago, I come back. And so it's something in my hometown, and so I'm happy to give you a talk. Now, as you can see, I'm more involved with computer society. I run conferences, all the things. So one of the things about conferences, coming to the conference keynote is not just to listen to all the other peers, but give you opportunity to see something new and basically let you have an idea for next year. So hopefully, in the following, give you some idea what it is. I think I gave the chart to the conferences, and if you want, you can get a copy. It's a long presentation, but I will try to give something to whatever in there, and you feel free to use whatever you want. I graduated from National Taiwan University. I went to University of Illinois, Urbana-Champaign. I worked at IBM Research for 30 years. 10 years ago, I come back to Taiwan. I work at, you see this, I work at a company. Basically, I'm from research to a way to doing called a system. The company I work for called Inventec is one of the major called the ODM. I think we basically building the device that you're carrying, the phone, the watch, the PCs, the servers. Later we'll talk about all the craze about the AI. So it's we call a system. Basically we build things. Now the interesting thing is if you look at the whole scheme, the bulk of the profit go to the company in Silicon Valley. Actually, all the major profit go to Silicon Valley, then go to all the cloud service provider. And for all the people in Taiwan, all you're saying is you don't make the silicon, so you make whatever you get. But in any case, I think what I want to tell you is how is, your highlight is called the system, linking system and service and solution. But what I want to share with you is along the years, you can see I have a gray hair, so it's been a while. If you follow the world evolutions, there's many stages, many phases. How you see there's a constant change, people looking for new things, people looking for new ideas. And so what I want to tell you and share with you, if you walk away from this is, well, people were saying, I have a great invention. But you do know, great inventions give you satisfaction. But great innovations, that is the people benefit from all the reward. So let's talk about, this is what I'm going to talk about. What is innovation? How can innovation be trained? And what we're always saying is, it's time for me to invent, to find something new. But discover something new, invent something new, versus finding a new way to use it, to create what we call monetize it. And then along the way, there's many technology change along the way. World is evolving, technology is changing, things is moving at a very rapid speed. And all these new things that will trigger what they say, new way of using things. So, and cloud, edge, you probably, if you are in the industry, if you follow the news, AI is everywhere. It's in the center stage. Whether the China and the US disagreement, Middle East, and tariff, anything you name it, I think AI is in the mainstream. Then we'll talk about some of the new things, how you're using these technologies, and maybe some of the things can give you some idea for future development. So there's a subtle difference between invention versus innovation, right? You discover, people filing patents, you generate new ideas, great. But always at the end is how the innovation, people taking the new idea, find a new way to using it. So what we're saying is, what make you innovative, right? People probably can give you all of their own point of view, one way versus the other. But regardless of that, I think somewhere in there must fit you. It could be a government, it could be an enterprise company, it could be a university, it could be a research agency, or you could be just yourself. But how we doing this is, and then so there's a many question is how you get there. Well, look at this, it's showing people's age, right? Long time ago, well, some of people, 1970, probably you are not here yet. Some you are here, some you're not. At that time, I think that's the world is dominated by system. And we've got a hardware, right? Mainframes. And then come along saying, I have a great hardware, I need some software to using it. So they start to a lot of way to using those hardware. Sensors machines, all these steam engine machinery. Then people say, it's so hard for me to use the great software, the great hardware. People building software to sell hardware, building service to sell hardware and software. And as soon as you hear about, is this vertical, meaning is this for aerodynamic, is how you making an airplane, making a boat, making a car, right? So then we think, I want something for a special purpose. Later part, I think in early 2000, that's the Internet of Things, Internet of everything, right? So the world full of sensor, you get all instant data, you can make sense out of it. And now we are in 2025. As of today, in the next 10, 15, 20 years, AI and ESG. I think AI is everywhere, right? And we will talk more about that. The other one, I think the new buzzword called ESG. This is called Enterprise, Social, and Governance. Oh no, I think Environment, Social, and Governance. Basically, in today's world, the world has limited resources, global warming. So as a good social citizens, we need to be energy efficient. We need to worry about the societal, right? We have to make sure of our government. But you know, ESG support, ESG is critical because bank will look at you. If you don't have a good ESG score, you are at risk. They don't want to loan you money, right? And if you are a supplier to a car company, if your ESG score is not good, they might not get a contract. So everything on the service is one thing. There's a government regulations. Government is worried about the carbon emission, global warming, but some people disbelieve that's the reason. But in today's world, you want to do business, you have to follow the new normal. So, but then along the way, you see this curve is not a smooth curve, meaning is there are disruptions. And you invent new things, you find new way to use it. So, now, by the way, just let you know, these charts all make about 15 years ago. So after 10, 15 years, I think still valid, right? On the far left, I don't think most of people know about IBM. I come from IBM a long time ago, so the IBM has something called 360. That's a census machines. That one big 4 rooms of all the hardware, software, your iPhone have more computing power than that. And you consume far less energy. But people saying, well, isn't that nice? Well, sorry, now everybody carry one phone, maybe 2, maybe 3, right? You travel, so you carry a phone for US or for Europe, and you carry a phone for local. So now you realize people carry multiple phones. And then PC, right? In the beginning, people say, people don't need PC. Everything was central. So now you know, everybody have PC, have laptop. And now, interesting enough, tablet. And now people say, my phone, the big phone, the trifold phone. So it was changing, getting information, the browser, and now most last piece, the cloud, the big data, everything. So if you're seeing all this, interesting enough, right? We are part of it. Now, anyway, I think what I'm saying is history always repeats itself. One of the other thing I want to say is about 10 years ago when started internet or seeing internet or everything, you get sensor everywhere. One interesting example we want to show is, I live in New York, so we like to say, you want to go to Friday afternoon, you want to go to New York City to listen to opera, to relax. I'm driving to New York City, and New York traffic is terrible. So before you drive, you want to tell me what route I should take. When I go into New York City, you had to direct me to where to park and where I can find the right parking space for me to listen to a concert or Broadway show. If you're from New York, you know what I mean. From whatever city, right? And so, if you have all this information, you know where the parking space available, can you make a reservation? And of course, you have dynamic data, you will know. You're going to do a dynamic pricing, or in a nice term saying, I want to make sure I balance it in the other way. They want to check out. When some place is shortage, then you make a very high. So if you take a Uber, another example, Uber rate is very dynamic, right? So that's what I'm going to say is, how can you have more dynamic way? Now, how you know this parking space is empty? You put a sensor, or you pick people that are walking around, or put the sensors. How you get more accurate information and better modeling? Of course, now you know a lot of people making sensors, keeping real-time data, trading parking space, trading tickets, right? So a lot of business. But this picture, by the way, how many of you have listened to this leather jacket person? I think he's a proud, he grew up, he was born in Taiwan, of course go to US. Jensen, right? Anybody? Right? I want to say this. If you don't know this guy, maybe you need to study a little bit more. His talk is like a concert, right? You go to that place, go to security 2 hours before. After the talk, you walk away, and probably you don't know most of it. I apologize that, but you have to be a domain expert. And you walk away excited. And then waiting for go through the traffic. But one thing I want to say is, there is another interesting word. It's called the perception AI, generated AI. Gen AI, I think probably use the ChatGPT, OpenAI. If you don't use it, you basically can talk to it more intelligent. On the behind, it consumes a lot of AI power. And then called agentic AI will give you advice. And the last part is physical AI. It will connect to the robot. So this just tell you now, because all the technology, everything is different than before. And things is changing in a much rapid pace than before. So one of the things is where you find your innovation. is like where you find your research topic. And in the old days, I think, well, it's another old joke is, what is the best search engine? Do you know? The research assistant is the best search engine. As a professor, you tell your students, say, I want something, it's like something you can find somewhere, I'm not sure exactly. But the next day, the research assistant will come up with something, is this what you want? So that's the best search engine. Well, of course, that's a joke. And research assistant also is a good example of agentic AI. They have their own mind. Your professor saying, I should go east. The next day you'll say, no, west is better. So, but how you find innovation, how you trigger it, and how you're doing it. Now, a lot of time, innovation was because you want to find some optimal way. You want to save costs, save manufacture costs, save something, whatever. Then so basically is you want to optimize. When you can optimize very important, you have the right data. So how you get all your data. Then is how you transform. So you know like new business models, how you sell. So you sell something from US to Africa. At one point people say, oh, or you say something from China. But you know, in those countries, they go through the technology eclipse, right? They didn't go through a landline. I think most of you, I don't know you watch TV, cable TV anymore. So most people are doing streaming. For newer generation, phone streaming is a normal, right? And of course, sustainability. So given all this, there are a few interesting trends. One is, I mentioned earlier about agentic AI. AI, instead of you tell AI saying, go wash my dishes, do my laundries, and now you just say clean the house. So they have their own mind. But those things also had to learn how to behave, human behavior, right? So one point is, in the new world, the language specialists, it's different phases. The world start to look at different part of technology. And then, of course, post-quantum, right? A few days ago, quantum computing, again, gaining momentum. People are going for the next generation. For those people, newer scientists, post-quantum computing will be the next area paying attention. And of course, energy is, I think, if you listen carefully, everybody worry about energy. We are short of energies. And then the last part is robot, right? How you interact with a human. So more and more, the language model, the language model, video models, a kind of thing is, I want you to observe a stream of pictures, figure out, is my assembly, my worker follow the right way to assembly, or is there some anomaly? And so this is long time ago, they were saying is, I think the good old example is when GM and Ford, during the Second World War, they're doing the assembly line to making all these, end up when they're making the car, automobile manufacturers, they're using the assembly lines. And now the new trend is, I want all my line manufactured by robot arms. So, you know, the assembly lines, McDonald's, chain stores, cloud computing, and also a bunch of government regulations. So there are many things is pushing the world to drive new things. And so what we're saying is a typical, you have to look at the end, we say, called a vertical, right? Making car, making boat, retail store, energies, and transportation, railroads, right? They all have their vertical. So there are a lot of rooms. And of course, energy, how you get cheaper, renewable energy. And now, to put this all this is, we are basically saying is, so as an engineer, can you give me a manual? Give me some kind of document. So if I follow what you said from step 1 to step whatever, out of it, I come out my next great idea. But all you know, the world is not that simple. That's why we need to exist. I will help you to be that. So there's a few ways out of this is, we call us, we'll help you to be innovative, or call us, we'll help you to build your innovations. But joke aside is no doubt, right? It's a funnel. You need to have idea, you need to open mind. You have to go to a lot of conferences to make friends. You have to talk to all the senior in the domain, and you have to networking and go to conferences. And so I think what I want to say to this is, it's a journey, and the way the technology, the things, the world, everything is moving much rapidly. And so how you going to be able to find it, and is now go through this called as academic scientific portion, the framework portions, that look at a few things. Cloud computing, for a lot of you, you are living it, you're using it every day. You use Gmail, you're using search, you look at YouTube, you listen to Spotify. How this thing possible is because of the cloud, right? This book company in Seattle, it started as selling book. To sell book, online book, they need to set up infrastructures to enable for people to put their book to sell, for people to search their book. And later part, they're saying, why don't we digitize the contents? So they sell online book, and they realize I can deliver digital contents. So they start to deliver music and videos. And at the end, they're saying, how about I make my own digital content, make my own movies? And of course, you know, that company in Seattle. And all this cloud, in the beginnings, it's just saying, I give you a more simple way, right? I build infrastructure for you, you figure out what you want. And another very important thing is, you don't need IT teams. All you need is a credit card. Give me your credit card numbers, and I will charge you. And you can start to spin in the meters. And you can start any times. There's no risk. You don't have to you don't hire a bunch of people building up a warehouse of equipment, right? So, but in this, a lot of engineers, a lot of scientists had to figure out what's the infrastructure, what's the platform, what kind of service you want to offer, right? And then the business, right? If you look at it this way, so this is one angle, just saying, I make the system with one. At that time, there's a term called elastic. It was stretchable, and I make a different kind of center in US, in Asia, in Middle East, and they'll help you for, if some place is overloaded, I can easily move it for disaster recoveries. And in there, there's all kinds of service, right? So the most important, underneath that common service, by important part is they provide the charging, the building, and the most important part is you can use it to build new services. So I think for the cloud, you live in this world long enough, no need to explain. So, but it's kind of interesting. People saying, I want to quick start. I don't want to build IT. Or somebody already have their own in-house. Then they decided, oh, it cost me too much to build my own infrastructures. So they went outside. So there's IT and business. So there's a two sides. There's a debate between IT and business people. And business people always saying, we have the best search engine, we have the best content. You go to the cloud, you don't know where to go. Maybe end up somebody own it, and you might lose everything, all your precious asset. So a lot of interesting companies, you know, in the old day, before the cloud, everybody had their own IT, their big infrastructure teams. But as time progressed, they realized it's too costly to keep up. So they outsourced to all the public cloud. And then when they look and say, every month I pay the public cloud company a couple of million US dollars. Why don't I build my own? This kind of back and forth. But nonetheless, there are many things cloud can provide you, right? You can grow. Some of the business, there's called a peak and valley, right? Thanksgiving, Christmas is a big thing in the US. And in Asia, Chinese New Year. So more and more this online system was built to handle this sudden surge for the event. So cloud is good. The other one is I can submit my jobs for printing, remote printing. And also, I need a lot of extra space, computing power, if I need to do some DNA sequencing, right? So there are a lot of application in a cloud-based, up and down. But cloud is just the beginning. I hope you get that. And the other thing is called the edge. There's something called data center, mainframes, then PC, then device, your mobile device. So cloud and edge are kind of two edge. There's a pooling. Now, more and more edge gaining attention. Now, if you look at from the left side, right? If you go from the top is cloud data centers to make it, you have a low latency, so there's a regional. So every geography, they have local data centers. And then in the local data to your factory or to your office, then there's edge. And then there's how you putting all your, we call the sensor data, feed into all the cloud data center. And then at all the end is the Internet of Things and people, right? So a lot of things, if you look at from the cloud point of view, is in the OT, you mean the operational. That means in your factory, right? You have all the machinery in the factory. When they run in the factory, they collect the machinery data. They want to make sure the machinery data is gathered, and then Internet of Things connected and edge. So and then Gen AI is a fun things. So people are start to collect, putting their factory data. When it was last maintained, what's the problems? And usually it's in some kind of log, in some kind of data book. People start to put this into system, and now you can say, well, this machine, when people come, when was it last maintained? When was it, any other machine has similar symptom? Who performed the maintenance? Who performed the last repair? You can just talk to it instead of you just look through the system. And you know, when the technician starting all the work, information retrieval and write time, so Gen AI. And of course, so all the things, because of this, we want to make information. So in today's world, all the Gen AI, agentic, are become a mainstream research. And so to be specific, in the real-time edge, one thing you'll do is in the car, do you know the new EV? I don't know how many you drive in the electric vehicle. Or a newer vehicle, they have all kinds of control unit. There's all kinds of computing, all kinds of sensor in it. So your car will talk to each other, talk to the roadside unit, so the car can be more efficient for your car. The next is inside the factories, all the factories data, AOI, augmented assist for the inspection, optical inspections. So in the factories, more and more image were used. So people in the factory will monitor the assembly worker. Are they follow the same installation procedures? Do they follow the right sequence? And after that, for all the product, we'll look if any defects. So that's factories, and of course, health. I don't know how many people really wear your watch or the wristband, right? They carry all your vital signs, your heartbeat, your blood pressures, your oxygen levels. Even can detect your EKG, all the informations fit into the system. And we have researched, people look at your EKG to predict whether you have a potential heart problem in 5 years. So is you wearing all these devices and you monitor it carefully, they do have a lot of potential to show you early warning and early risk. So, we carry all the devices. And then, of course, at the end, in the retail store, I think retail is one of the area many people paying a lot of attention. How we understand the retail behaviors. And so we put camera on the self-checkout to make sure people doesn't walk out without paying, or they pay the right things. And of course, we're saying we just want to preserve everybody's security, safety, but for all the retail store, they just want to make sure they protect their profit. And also they can check the people buying patterns, they can check the inventory levels. So more and more, and so at the end is how the phone, the device, edge is building this. So I want to say it's a federated, right? Federated database, federated research, federation coordinations. These are all the things that's been around for quite some time. So anyway, edge one, I want to tell you a lot of fun things. We're saying is old versus new, right? Glasses. I think we carry wearing glasses for long times. And Google have been trying to do a Google glasses and Google Watch. They are adding things. So people were saying phone basics take care of many things, right? So with a phone, you don't carry, some people phone, you don't carry watch. You don't watch TV. You don't carry cameras. They take away a lot of what we did have before in a very rapid pace. Now, how about glasses? Okay, so in the glasses world, what we're seeing is many glasses people have tried, but it's not successful because it's very, I would say, intrusions, very aggressive. When you carry this, you look like you are, look at me, you are taping me. And so there's a new generation of glass coming up, Ray-Ban, very fashionable. and you will find a way, have a better design. And so there are newer generation of glasses coming up, helping people to capture surrounding. So that's the glasses. The other part is robot. In today's world, people getting old, lack of resources. So robot is a new trend. There's all kinds of robots, and humanoid robot is in the center stage. But doing the robot, there's one thing is important is, are you doing the joint? Are you doing the brain? Or are you doing the software? And we all know software is the soul of all these robots. So robot is another thing. The other thing we look at is marine PC. Marine PC is something for you to use in the boat. Driving a boat is like driving a car, navigate a car or driving a car. And so there are more and more people putting attention to the marine PC. And there are many companies doing the marine PC. So marine PC is helping a way to help you on navigation above water, under waters, and then healthcare. Healthcare, another key attention is whether you are in the operational room before, after, at home for recoveries. So more and more technology have been deployed to improve the healthcare technologies. So I think what I want to say, well, sorry to rush through, is the AI, the edge, how you do a federation. So a robot with drones, with multi-coordination, with all the data, and then how you deploy the robot to do more for the caring, or elderly caring, or doing worker in the factories, and the glasses. And then, of course, I didn't talk enough is the energy portions. All these devices consume a lot of energy. How you build things is more energy efficient. So I think innovations, if we want to say there's a process, I think there's a journey and lesson learned, and how you capture it and how you refine it. But what we learn is all the innovation and technology, human is the enabler, also the biggest inhibitor. So how you embrace it, or you could be a potential the roadblock, whether in the company, in the government policies, and how we adopt it. And you can see many times, the innovation people are the guy, they can monetize it and driving, and of course, we all say is, we do it for the mankind to help people have a better life. But thank you very much.
Thank you, Dr. Cheng. We have time for maybe one or two quick questions, if there are any questions from the audience, before we move on to our next speaker. No? Okay. Thank you very much. Thank you for those. Thank you. Our next speaker is Dr. Charles Tai. He is currently the General Manager of Hydrogen Energy Applications and New Business Development Department at Delta Electronics. Since joining Delta in 1997, he's accumulated over 2 decades of experience in the ICT and energy sectors. Beginning in 2008, he led the development of data center solutions, strengthening Delta's technological advantages in sustainability and energy efficiency. He successfully delivered high-profile projects such as the 100-megawatt air trunk data center and global UPS projects for AWS and Microsoft, showcasing outstanding system integration capabilities. Since 2022, Dr. Tai has spearheaded Delta expansion into the hydrogen energy sector, integrated solid oxide technologies with Delta's energy foundations, actively advancing towards a low-carbon future and opening a new chapter in sustainable development. So please join me in welcoming Dr. Charles Tai.
everyone. This is my honor to be here to give a talk. And I think especially today's Po-Tai session. I know Po-Tai around 25 years after he got a PhD degree and returned to Taiwan. We cooperate every year and until he's sick, and we never stop. And his research achievement already implemented in our product line, and his student work in Delta is very well. Thank you, Po-Tai. As turn to the current today's topic, I would like to talk about the challenge and the opportunity for green hydrogen application. This presentation have some problem? Okay, good. I have, first I think I introduce myself and our company. I got a PhD degree from National Cheng University and then joined Delta. From year 2012, I am the general manager of Delta mission critical infrastructure solution. This for data center power and cooling solution for the global operation and channel branding promotion. And from year 2019 to year 2023, I'm as a CTO of Delta ICT BG. This business group is around 3 billion on revenue, focused on the telecom power system, UPS and the data center, and this networking system. And in year 2022, I established Delta Hydrogen Energy business. And from year 2024, I dedicated for this operation. So I talk about Delta Electronics. Delta actually is established in 1971. Our founder is Bruce Cheng, and we are global #1 market share in the power supply and DC bus fan. And we also the major supplier in data center, AI data center infrastructure and energy infrastructure and automation. And we also the key player for the EV powertrain. And this is our company mission. This is to provide the innovative, clean, and energy efficiency solution for a better tomorrow. I think this is the reason why we step into hydrogen. Why is green hydrogen is very important? I think everyone know about climate change. And I think you can see it, you can feel it. And from a scientist's point of view, we can measure it. So climate warming is become a major issue for the humankind. So this Delta, we consider this one opportunity for Delta. And from the IEA, let's talk about if we want to target the year 2050, if we want to achieve a net zero, we need to reduce the 36.9 gigatons for CO2 emission. How to do that? One is we need to have a better energy efficiency, how to use our energy. Second is we need to do our best effort to do the electrification, and then every electrical power come from the renewable energy, even as nuclear power. But people prefer renewable energy, right? And if we do everything possible, we still, in some application, we still need to have a few, use traditional fuel. So we rely on the carbon capture storage, this kind of technology. But in the end, if we still cannot resolve this issue, we rely on the hydrogen. So the hydrogen is the best mine to do the net zero. So you should try to resolve the very difficult things. We cannot do the electrification. So from this fact, I give because we are talking about energy. One is the fuel. If we can consider the fuel, we consider the volume, energy density. Second is the weight, the weight density. So you can see the decent. Sorry. How to come back?这怎么回去啊？ Oh, okay, I found it. Okay, you can see this lithium-ion battery. This we are used to for the like the passenger car or anything, and you can check this one, the energy density for lithium-ion battery, from the weight or from the volume point of view, is very low. So and the hydrogen is more than lithium-ion battery, as 120 times about the lithium-ion battery from the weight point of view. But the problem is from the volume point of view, this is not a good solution. So a traditional one, like we use gasoline, we use diesel, and for airline, we use airline as fuel. So if we want to, in the future, we want to go to the net zero, ammonia may be a good choice. Yeah. For regarding the power generation, we can do if the power generation between the 1 megawatt to the 100 megawatt, maybe combined cycle is not so popular in this power range. As a fuel cell is a better efficiency than other power generation. So we know this one, so we come back to our original problem. It's from the market point of view, the green hydrogen increased 6 times from year 2020 to year 2050. So this kind of increase actually is we are focused on some of occupation. One is the original. You already use the hydrogen. This is traditional use gray hydrogen. Right now we move to the green hydrogen. This like the ammonia we use and like some of gasoline production refining process. And the second is steel making. We traditionally use coal for steel making, and right now we use hydrogen. And for the long-term transportation, we also we cannot use a lithium-ion battery, so we can use different synthetic fuel for deep sea maritime and air aviation and long distance trucking and rail. And for power generation, actually, for the power system, we still needed to keep some of basic initial in the power system. So maybe as use ammonia or use green hydrogen for the combustion engine is still can consider that. And for long duration, maybe consider more than day, more than the season. You can consider use chemical energy storage as long duration energy storage. Hydrogen is an option. And if we consider CO2 emission, this is free. We don't need to consider any green hydrogen. So this the policy from IMO. IMO means International Maritime Organization. They say they will conduct the program, and they set the roadmap for CO2 emission. If your emission over your target, 1 ton, they will charge 380 USD dollars, not NT dollars. So I think this is will drive the market demand. And you can see this one is currently in the worldwide the green hydrogen or related project. And you can see the blue one, the big one is 112 project already in the pipeline. And this pipeline, more than a gigawatt. And for the larger scale, this means more than a 500 megawatt system. And for 191 is around 200 megawatt. So if we consider the hydrogen industry, normally it's a very huge project. So I think this why people hydrogen. I think this we know that, and how to bring down the cost, become affordable is very critical. And I think this is the biggest challenge for us. And currently we cannot certify this kind of demand. So actually, from a business point of view, this is our opportunity. So as a Delta, what are we going to do to face this kind of challenge and to catch this kind of opportunity? From a technology point of view, currently in the market we have a different technology, and in the different technology readiness level. For alkaline, it's quite mature, but it's very difficult to direct can match the renewable energy. Second is the PEN. This is a kind of technology for the electrolysis. It can match the renewable energy because the dynamic is good, but they use a very expensive material, so maybe still have a problem. And this one is very sensitive to the quality of water. And SOEC is a technology not still in the level 8 and maybe going to the level 9. We are going to do the larger scale demonstration. This one considered the most energy efficient way to generate hydrogen. And AEM is one technology want to replace the PEN, but still in the very early stage. Consider the higher energy efficiency. I think I have two different technology. One is same as a solid oxide cell, but a different approach. One is a metal support cell. The other is electrolyzed cell. From the technology point of view, this one, we as a Delta, we are working with Serious Power for this kind of technology. And Burn Energy and in Sunfire in Germany, they use this kind of technology. The operation temperature is lower, and structure-wise, we have a metal support here. So the thickness of this ceramic is smaller, and the other one is bigger. So from the structure point of view, these are much better. And the life point of view and the thermal cycle point of view, this metal support cell have a better performance than the other approach. So in year 2024, we signed a technology license agreement with a UK-based company called Serious Power. He's spin off of UK Empire University, and we are focused on the solid oxide and the solid oxide electrolyzer. So we established our team in Tainan Science Industry Park. And we build our lab here to do the system test and some of the material validation process. And we are planning to have our first production line next year. And we also plan to go to the mass production coming soon. And I established this team, and I set the goal and our vision for our team. What is our vision is we want to become the critical contributor for the affordable hydrogen energy solution. I think there's some key word is the most important. This is affordable energy, and we want to become a solution provider. We know how we just not just to provide the equipment. We provide the solution how to use our equipment, and critical contributor is means we will become the one of a major share in the market. For Delta, actually, we are focused on two technology. One is for SOFC, for power generation. Second is SOEC, for electrolyzer to generate the green hydrogen. Our technology actually is compared to traditional one. The energy efficiency better. It's save around 32% of compared with traditional alkaline and the pen. And for water, we also have a 30% saving. For Delta, we built our own factory for sale and build our stack, use Asia and the Taiwan supply chain to bring down the cost. And we bring Delta automation capability to make the product to reduce production cost. And we design our system and we develop our solution for our application. So for SOFC, we divide the different product, and for SOEC, we also provide to the market. We sell the stack and the rectifier and our system, and we are focused on the power to S application, how to integrate our system and hydrogen or ammonia production, all the process together. First, I talk about SOEC. I think this technology is the best choice for the power to S application. This is the system architecture. It's the input power from the renewable energy. So, and we converted the AC to the DC and go to our electrolyzer. Sorry. And this for then generating the hydrogen. You can directly use in the industry for steel making or for refilling station, or you can combine with nitro to use a hub process to make the ammonia, or use a fish trap ship process to make the like e-SAF or e-fuel. So you can compare the energy efficiency from different technology, like the pen, like alkaline, and SOEC with the steam. The power consumption, we want to produce 1 kilogram, you just need to around 38 kWh. And compared with the traditional one, you can see our energy efficiency quite flat, and it's much lower than the other technology. And to the overall, we use LCOH to consider what is the benefit for this technology compared with the traditional low temperature technology. As system efficiency is more than 55 kilowatt hour per kilogram of hydrogen production. And if we set a goal, 1 year we want to produce 1 million tons for green hydrogen. This one is electrolyzer capacity, and this one is the renewable energy you needed to install. So you can see this one is much better than others. And for hydrogen application, we also can combine we call co-electrolyzer technology. It's a combine CO and CO2 and steam. We can go to the electrolyzer and produce H2 and the CO for future process use. And this is a very important technology. And for SOFC, I consider this a very ultra low carbon dioxide as energy for on-site power generation. This is our product offering. This for enterprise application and the industry application. We have a 550 kilowatt system. This is configured from the 5 SOFC power module and the power distribution and the central cabinet for the suffering system and the DI water making. And this for 1.1, we can use 2 subsystems. And for 5.5, if we are considered for large system, we can use a 5.5 megawatt system. And if this is a large system, we can use a tower type. So these are for small one to the bigger one, and you can install by your demand. And that is our system architecture. Here, you can see our solid oxide fuel cell. Because it is the output of DC, and we install another DC-DC converter, become a 5.5 megawatt. And that is a DC voltage around 1,000 volt. And go to our PCS. This is a green forming inverter connect to the grid. And here, we also have a CBU, use a supercapacitor to compensate the dynamic, because chemical reaction and the mechanical reaction is slow and low the dynamic. So we use CBU to compensate to meet the system requirement. And the input actually is for the infrastructure point of view. Natural gas is right now still is more popular. So we use natural gas, and inside the solid oxide fuel cell, we have a reformer convert to the hydrogen. And the tail gas actually is contain a lot of steam. So we have a steam separator to absorb the steam. So we can generate the pure water here. For the other is some fuel and the CO2. So here the CO2 emission, the concentration of the CO2 is much higher than other power generation, like the coal generation maybe 12%, and for natural gas maybe 8%, but here it's more than 60%. So for the future carbon capture, this higher concentration means the effectiveness and efficiency is much better than lower one. And if we combine do the energy recycle for heat recovery, This one is around 25%. So combine power generation and heat recover, total power energy efficiencies are more than 85%. This is the reason why we say this ultra low carbon energy for power generation. And if we currently AI data center is people are consider we are lack of the power. So how if we are traditional data center, you want to add more power, you can use and your electricity cannot supply. You can consider use a fuel cell to your data center. As a Delta, we can provide the different power and the cooling solution from the IT rack. In the motherboard, we have a DC-DC converter, have a different power supply and switching network, and different cooling solution, power distribution, large scale UPS. So we provide the overall solution, and right now we can provide the SOFC for data center application. This one is for the I think maybe you know it's NVIDIA. They are ultra rapid NVL 765. It's were launched in year 2027. It's the one server rack, standard server rack is consume around 800 kilowatt and use 800 volt to power their server rack. So this one is the solution to power their IT rack. It's combined. We can provide 800 kilowatt to convert AC to DC, and we also provide the BBU and the CPU to compensate the dynamic from the GPU. So these are the solution for future AI data center. And for solid oxide fuel cell, we have a different configuration. The first one we call the AC microgrid. This one, fuel cell, we added a CPU here and the PCS here, and this we call sidecar to provide the IT power, and this is AC power distribution. Here maybe 480 volt or 600 volt AC, but this one, like Google or Microsoft maybe adopted this one, use 800 volt as a power distribution. So we just remove our PCS. Here we direct provide the power here, and this one from AC to DC change to the DC to DC. This may be a small DC-DC converter. So Delta can offer AC microgrid solution and DC microgrid solution. This one, I use this one to conclude in my presentation. For SOFC on-site power generation from the sustainability point of view, is we have a better efficiency, so CO2 emission is lower, and for SOFC there are no SARS and NOx, so there are no air pollution. We don't consume water or we store water for cooling. We produce the pure water. So from the this point of view, is how time to power is very critical. We don't need the environmental impact analysis assessment. So I think it's a speed up, and that is a modular design. So it's maybe build a system from the multi-years to just a few months. And for flexibility point of view, this resilience is very important, especially for Taiwan. So microgrid is a good option for this kind of solution. And the second is the fuel, maybe choose natural gas or future or hydrogen, ammonia, have a different option. And there's from the reliability point of view, is on-site power generation. We don't have overhead power distribution. So this, I think, is more reliable. So this from the future point of view. But if we go to the real dollar sign, this is also very important. I don't use Taiwan case. This is too sensitive. I use Singapore. Singapore is around 95% is the fire power plant use natural gas. If they use a grid around 20 cents, 20 cents around $6 NT. Taiwan is only 4. And the LCOE around $5, $5 NT. It's the LCOE. Another $1 come from the power transmission and the distribution, and these are their configuration. But if we will consider this in the critical power application like the data center, we needed to add more because this double feed to make sure this tier 4 data center. We needed to add more cost in that. And if we consider this fuel cell, we don't need it's a power generation and use their natural gas price. I think we in Singapore is more realistic. But we hope in Taiwan the society is more reasonable to discuss what is the reasonable price for electricity. Thank you.
Thank you very much, Dr. Tsai. Well, please stay. Yeah, because we have time to take the 1 or 2 questions from the audience, and you can see here, this is basically the way we organize it. We look at it from the infrastructure side, the cyber side, and then to the physical side, to the component, and then to the system. So it's basically a well-planned plenary discussion here. And so from the audience, do we have anybody? Yes. Can you go to the microphone, identify yourself, and then give a brief question?
Hello. I'm Brian Pong from the National Taiwan University of Science and Technology. And thank you, Dr. Tsai, for your presentation. I have a question on the AI power server. What are the main challenges? Because I understand that it demands a lot of power, and what are the current demands? What are the current challenges of these power supplies?
Thank you. This is a very good question. And I think we from the lot of reporting, AI is very strong demand. And actually in Taiwan, there's many companies, including Delta, we grow very well, especially for the AI data center, not only for the power supply. We also have a very strong demand for cooling, especially for the liquid cooling. So what is your question is what is the challenge for the power supply? I think one is power supply from the large scale point of view is in the energy power from the grid. This is first challenge. Second is because semiconductor, the progress of the semiconductor, you can see 600 millimeter the wide of a server rack consume 800 kilowatt. It's a traditional, if you, as we in the school, university, the traditional data center, one rack only consumes 3 kilowatt. It's these are very different. And how to do the power distribution, how to do the deny the power supply, what is the density, because original computer big, and then due to the semiconductor progress, the size of infrastructure become the major portion of the infrastructure. How to make our infrastructure, their power density, energy density, have a bigger, significantly improvement is very important. Yeah. So regarding the data, power supply, there's a lot of work needed to do. And in Delta, actually, we have some solution, not only for on-board DC-DC converter and the AC-DC converter and backup power. We have all solution for that. And we work with the customer very close. Yeah, thank you.
Thank you very much. And I have a brief invitation to Dr. Tsai that IAS, we are try to submit a PAR on the modular data centers. And so try to develop a standard over there. So that is basically Delta can play a very important role. So we would like to, the engagement from your, yes. Okay, any other question? Okay, well, thank you very much.
Thank you. Thank you.
Well, our next speaker, and the topic of his presentation is development and application of distributed battery energy storage system in the Taiwan power system. And the presenter is Dr. Cheng Wu. Okay, he is the Vice President of Taiwan Power Company. He has a comprehensive academic and professional background, and with extensive practical experience in power operation. He received his BSEE and MSEE degree in electrical engineering from National Power University, National Taiwan Institute of Technology in 1990s and 1993. Yeah, and then he obtained his PhD degree in electrical engineering from National Taiwan University of Science and Technologies. And he also spent 5 months at our campus, University of Texas at Arlington. So I know Dr. Wu for a long time, and he is actively support energy transformation by integrating demand response and energy storage systems through innovative model, participating in the provision and the ancillary service, assisting in integration of renewable energy into the grid, and ensuring a stable power supply. Additionally, he is responsible for planning and establishing a power trading platform, expanding private sector participation, and promoting domestic energy technologies, innovation, and the development of the energy storage industry. He has been invited multiple times as a distinguished APEC expert on power and energy to participate in grid and energy transition forum, achieving remarkable performance and outstanding result. So Dr. Wu is a registered professional engineer in Taiwan, Republic of China. Let's invite Dr. Wu.
Okay, good afternoon, everyone. I'm Jun Wu, Vice President of Taiwan Power Company. Today, I'm excited to share how Taiwan using battery energy storage system to build a more stable and flexible power grid. Here's an overview of my presentation today. Let's start with the current status of renewable energy in Taiwan. Okay. By the end of February 2025, our grid-connected capacity reached nearly 4 gigawatt for wind and 14 gigawatt for solar. In 2024 alone, the total renewable power generation hit 25.23 billion kilowatt hour, almost 15 from solar, over 10 from wind. That's an 886% increase compared to 2016, which really highlights the strong momentum in Taiwan's green energy development. But at the same time, it brings new challenges, especially in terms of grid stability and feasibility. That's exactly why energy storage system, particularly BESS, battery energy storage system, are become essential tool to take our power system reliable and balancing the renewable energy penetration continue to rise. This slide shows how Taiwan's net load curve is changing as solar power comes online. During the day, solar purchase the net load down, but at once the sun start setting, especially around 3 to 6:30 p.m., the drop in solar output caused a sharp ramp up in the net load. On August 27, 2024, for example, solar output dropped by over 6.5 gigawatt. In just 3.5 hours, once insulated solar power hit 20 gigawatt, this evening ramp up could reach 10 to 12 gigawatt. It's a huge operation challenges, and it's exactly why we need more better energy storage system to help smooth this transition and stabilize the system. Here we can see the clear trend that intermittent nature of renewable energy is becoming more pronounced every year. Now we talk about the policy strategies for battery energy storage systems. In Taiwan, the policy has really paved the way for BESS to become a core part of the power system. Battery energy storage system not just for backup anymore. It now plays a key role across the entire power system. From a grid level service like frequency regulation, speed reserve, to customer side benefit like demand charge reduction. Battery energy storage systems can add value at every level. Our policies are designed to guide this system to what they are needed the most, so we can get biggest impact for both reliability and efficiency. Taiwan's target 1,500 megawatt of distributed BSS by 2025, with much of it integrating through the electricity trading platform. These systems are being deployed across grid, from supporting utility feeders and the PV integration to behind-the-meter setup that help customers manage their energy use. On the behind side, on the demand side, the BSS also supports service like time of use pricing, demand response, and regulatory compliance. By 2025, Taiwan aims deployed 1,000 megawatt for grid service and 500 megawatt for generation site. For grid service, this includes 500 megawatt for power tap and 500 megawatt for energy tap storage. So far, we have deployed 160 megawatt through Taipower and nearly 800 megawatt of the private resources for regulation, and another 584 megawatt is supporting energy shifting and the ED reg. On the operation side, the Taipower has installed 160 megawatt of battery energy storage system across several key sites like Longtan Substation, Dongshan Substation, and Tainan Yantian Solar Farm. These systems are doing more than just the storing energy. They are providing real services like frequency regulation, energy shifting, voltage support, and even inertia management. What's more, we are using this system as demonstration project to show the private sector how BSS can actively participate in grid services. So it's not just about capacity. It's about capability and confidence in system-wide integration. Okay. Taiwan's electricity trading platform lets qualified traders, including BSS and demand response, can bid in the day-ahead market for ancillary service like regulation and spin reserve. This market set up boosts dispatch flexibility and make it easier for diverse resources to participate. It's a key step in opening the system to more dynamic and distributed players. This slide shows how different type of BS contribute to grid service, a grid reserve. Grid connected system can offer dynamic service like D-Reg and ED-Reg through the electricity trading platform, responded to frequency change and in just seconds, while also following a dispatch schedule for energy shifting. At the same time, behind-the-meter system can join as demand response resources, providing static regulation support where it's fast response or schedule shifting. Each BSS type play a unique role in keeping the grid stable and flexible. The PV plus BSS, the benefit include the stabilize the supply and enhance the nighttime the power and prevent the feeder congestion. It also helps the grid congestion by storing energy. With the support from the FIT, this setup makes renewable energy more predictable and grid friendly. Behind the meter battery energy storage system, giving customer more control over their energy use and more way to save. For example, user can shift their load to avoid high time of use rate and lower electricity bills. And by joining programs like demand response through the electricity trading platform, they can even generate extra revenue. So instead of just consuming power, customers are now actively managing and monetizing their energy. As of the April 2025, Taiwan's disputed BSS capacity had reached over 1,580 megawatts. It's still growing. Most of these systems are privately funded and connected through the electricity trading platform, meaning providing dynamic regulation service. What's interesting is that over half of the capacity is located in the eastern region. But due to how the grid is designed, much of the energy support the demand in the north. Now let's take a close at the technology behind BSS and how we use the information system to connect, monitor, and manage these resources. The specification for DREC. There are two performance requests, DREC 0.25 and DREC 0.5. That is for the DREC 0.25 is for dynamic regulation, and the DREC 0.5 is for the EDREC. The EDREC is combined. They have the frequency regulation, the responsive, and the energy shifting. But the dynamic regulation, only the two functions, responsive and the regulation. These systems automatically track the frequency change and respond in 1 second. When the system frequency dropped below the 59.75 Hertz, they discharge a full capacity, 100%. And when it goes above the 60.25 Hertz, they charge at 100%. Okay, there are two real-world events highlight the full value of the BSS in frequency control. In first case, it's on the November 28, 2022, 539 megawatt coal-fired unit suddenly tripped, causing the frequency to dip to 59.75. One 5 megawatt BSS unit drive in a full power, discharging instantly. Another real-world example this time is during a high frequency. On June 1st, 2023, a fault at the Lanka substation pushed frequency up to 60-35 Hertz. In response, BSS unit rapidly switched to charge mode, absorbing 168 megawatt of exceeded energy. This quick action helped bring the frequency back down and restore system stability, showing how BSS plays a vital role in both low and high frequency events. Specification for SREG. Unlike dynamic regulation, SREG reacts more gradually. It discharges when frequency falls below 59.88 Hertz and begin charging only when frequency goes above 60. It even used by behind-the-meter BSS participant as a demand response. While SREG is simpler, it still plays an important role in helping stabilize the grid during a milder frequency deviation. Here is a great example how even small BSS system can make a real impact. On November 28, 2022, the same coal-fired unit trip, a frequency dropped to 59.76 Hertz right away. 1.2 megawatt behind the meter SREG system from the Formosa biomedical responded automatically. The specification for ED-REG. ED-REG is like a two-in-one solution. It combines energy shifting based on schedules or dispatch command with fast frequency regulation. That means a BS not only follow a planning, charging, or discharging routine, but can also respond instantly when the grid needed help. It's a powerful tool for feasibility, and to qualify system need to meet certain specs, like a minimum 1 megawatt output and 2.5 megawatt hour capacity. During the June 1st, 2023 Lanka substation event, a 10 megawatt ED-REG system handled multiple tasks at once. It performed energy shifting, real-time frequency regulation, and even responded to sudden fluctuations. In addition to frequency control, BSS can also help with the voltage stability. It can operate in different modes, like automatic voltage regulation, fixed reactive power, or fixed power factor. Whether the grid deals with the high or low voltage, BSS adjusts reactive power accordingly to keep things balanced. BSS can also simulate something called virtual inertia. When system detects the rapid change in frequency measured by RCOF, it can trigger a fast response in under 0.2 seconds. That means battery immediately responded to inject or absorb power and slow down the frequency drop. This kind of phase response behavior is especially important now that we have fewer traditional generator providing natural inertia. Virtual inertia from BESS helps fill the gap and makes the grid more stable during sudden disturbance. To manage all these BESS resources efficiently, Taipower uses SD-WAN, a secure virtual network that connects everything in real time. Through this setup, the electricity training platform can send dispatch command, monitor performance, and coordinate multiple systems all at once. API also makes it easy to schedule, control each system based on market needs. It's a smart way to unify a growing number of distributed assets. Here you can see how our BS management system track both schedule and the actual discharge performance. This slide shows how the BS management system monitors real-time frequency and instantaneous power output. The red line is a system frequency. Blue line is the instantaneous power output. This dashboard from the Taipower BSS system shows real-time data on state of charge, discharge, duration. It gives operator a clear view of what ready for dispatch. This slide highlights how we integrate real-time BSS data in system operations. We monitor work capacity, system performance, and the status like power output and the state of charge. This kind of visual is a key to reliable dispatch. This is a great example of how we integrating distributed energy into the grid. Through the BSS management system, we can integrate information from over 2,700 substations, turning scattered assets into the variable grid service. This is ENEL-X aggregator, aggregates the Go-Go battery swapping station as a demand response resources, connect them to the electricity trading platform. Let's now take a look at how BS improving real-world grid operation. Stabilizing the power system frequency. BSS integration has significantly improved frequency stability. In early 2023, only 78% of the time was our system frequency within the type 60 plus minus 0.05 Hertz range. But by late of the 2024, a number jumped to over 94%. This shows how PSS is directly improving frequency stability and making our power system much more reliable. PSS also have with voltage control by providing steadily reactive power. It runs in two modes, automatic voltage regulation or fixed power factor. Since frequency control, since frequency regulation comes first, the reactive power is limited to about plus minus 50% of the PS rate capacity. Enhancing power system resilience. On April 3rd, 2024, a major earthquake in Hualien caused multiple power units totaling 3.2 gigawatt to trip, dropping the system frequency to 59.50 Hertz. The BSS responded almost instantly, discharged 510 megawatt, and helping stabilize the grid within 10 minutes. Combined with the support from the pumped storage and the rising solar output, the system recovered quickly and avoid breakout. This event highlights the critical role of BSS in enhancing power system resilience. Okay. This the Gogoro, the example for the demand response provided the S-rate. Real-time system inertia management. Here's an example of how we using BSS to better understand system conditions. During the 2025 Chinese New Year vacation, Taipower used 5 megawatt BSS at Dongsan substation to measure real-time system inertia. We find that on the January 29th, inertia dropped to just 137.68 gigawatt a second, a clear sign of how low inertia can get during holidays. This data help us plan stability strategies for future low inertia scenario. Conclusion and future outlook. Through the strong policy direction, target technology applications, and close collaboration between Taipower and the private sectors, we achieve our 1,500 megawatt target ahead of the schedule. BESS now plays a vital role across multiple fronts, stabilizing system frequency, supporting the integration of renewable energy, strengthening voltage control, and increasing overall system resilience. On the technology side, advanced service like DRAC ED rack and the vertical support have proven crucial in real-world events, such as during major generator trips and even earthquakes. Looking forward, Thai Power will continue expanding the battery energy storage system deployment, investing in innovation and enhancing system coordination through digital management systems. We believe that with the evolving energy landscape, BESS will not only support grid stability, but also drive Taiwan toward a smart, greener, and more resilient energy future. This is my presentation. Thank you for your attention. Thank you.
Yeah, thank you. Thank you, Dr. Wu. Well, probably I have to use this one. Okay, and do we have any question from the audience to Dr. Wu? Okay, so can you go to the microphone and then identify yourself first?
Okay, thank you, Dr. Wu, for your insightful informations. I'm a delegate for Taipei Metro. So I'm very concerned about our power stabilities. But according to your presentations, I understand that currently in Taipei you have 1,500 megawatt of battery storage system, right? And the system, as you demonstrate, that it helped to stabilize our power system in terms of frequency and voltage. But I have two simple questions. Do you have a target that in the future, how many additional power system, energy system you are going to install? And the second question is that system have some expected life expectancy? For example, 20 years or how many years you are going to renew that system periodically? Thank you.
Okay, thank you for your question. The first question is, I think we don't have a clear answer, but until the last month, the battery energy storage system installed capacity reached more than 1,600 megawatt, and now there are about 4 gigawatt. The capacity still the construct under construct, yes, and the most of the capacity is from the private sector. Okay, they provided the NSA service. Now it's two kind of NSA service. That is a frequency regulation. The other is the energy shifting. So in future, we need more and more energy shifting. Energy shifting, the better energy storage that support the evening, because just yesterday our renewable renewable generation create a new record, about the 12.3 or 34 gigawatt yesterday noon. Yeah. So yes, I believe the BESS is very, very important for the net zero for the 2050 in Taiwan. So the Thai Power now we also built a pumping storage in the central part, the Daja River, Daja Xi. Okay. This my first your first question, my answer, and because yes, the BS have a life cycle about the 15 or 20 years. That is very expensive. So Thai Power, we purchased the service from the electricity trading platform. That is a very definite in Taiwan, because can the financial issue that many the bank can join the renewable energy development to support the BSS, and we can provide the opportunity for the energy storage, the industry, domestic, and some the energy storage, the supplier, because they get the real service, join the Taiwan's energy service, the market, so they can get the experience, can join the other country like the Japan, the Australia, they get more project. Yes. So I think that in future, it's the renew is another big challenge. So I hope that is an opportunity for Taiwan. Okay, this is my answer. Thank you.
Well, thank you very much for Dr. Wu's presentation. And any quick question for him? Okay.
Thanks for Dr. Wu, excellent presentation. So I'm from Tianjin University of China, and I was also a professor in power system. So my question is very quick, actually. I saw you, even behind the meter battery is a large capacity, 2 megawatt hours in your example. Do you have a plan to integrate a smaller capacity one for the battery, something like, say, 100 kilowatt or even smaller one, yeah, like virtual power plant, something quite popular in Europe or even China, yeah? That's my question.
Okay, thank you. I think the behind the meter will be a big opportunity in Taiwan. But behind the meter have one challenge is the security. Because we know the battery energy storage system is have dangerous because the fire. So the behind the meter, the user must can control the risk for fire. So you mean the small scale, small capacity, the battery can install the home or the community? I think yes, they can, but they must prove its safety for the fire. Yeah, and the government request if the user contract capacity more than 5 megawatt, they should be set up the renewable energy or purchase the renewable energy all install the battery energy storage system. Yeah, that is the government goal. Yeah, thank you.
Well, thank you, Dr. Wu. Thank you. Okay, so last but not the least, okay, so we are going to have Dr. Chen that to present the application of high-grade electrical steel in green energy and the green transportations. So Dr. Chen is an Assistant Vice President of the Technology Division of the China Steel Corporation. He received his bachelor degree in mechanical engineering from National Taiwan Institute of Technology. Now is the National Taiwan University of Science and Technologies in 1985, and his master and the PhD degree in material science engineering from the National San Yat-sen University, Kaohsiung, Taiwan in 1992 and 1997, respectively. Since joining CSC, Dr. Chen has led the development and the optimization of the high-grade electrical steel technologies, including self-bonding ES for electric vehicles, AI applications, and the green transportation systems. His contribution has significantly enhanced CSC capability in delivering premium ES product with superior magnetic properties and energy efficiency. Dr. Chen's R&D effort focused on advanced non-oriented electrical steel for modern energy applications such as high-performance motors, transformer, and AI-driven devices. His work is a contribute to the reduction of energy consumption, increased system stability, and extended product lifespan in various industries. Dr. Chen promote partnership among industry, academic, and the research sectors to drive innovation in electrical and steel technology and expand application for high-efficiency energy systems. In this presentation, Dr. Chen will provide strategies to develop the premium ES for green transportation and correlative technologies developed for its applications. Let's welcome Dr. Chen.
Thank you, Mr. Chairman, for your kind introduction. Ladies and gentlemen, I'm very pleased to be here and give you my presentation today on the topic of some development and application that we did in China Steel on the high-grade and extra high-efficiency electric steel that is used in the green transportation. 4 sections will be given in this presentation. In the beginning, I will give a short briefing about my company. China Steel is founded on December 1971 at Kaohsiung City in the southern part of Taiwan. The CSC group steel capacity is around 16 million tons per year, and the capital is about 5.0 billion US dollar. The revenue last year is around 11.22 billion US dollar. The net profit before tax is around 0.14 billion US dollar last year. CSC is an integrated steel making company. The main process include iron making by blast furnace, steel making by basic oxygen furnace, continuous casting, rolling, annealing, etc. In order to reduce the carbon emission and increase the green competitiveness of our downstream customers, we are working very hard recently to reach the goal of carbon neutrality in 2050 in our mill, and also to provide steel products that can create core value and benefits of supply chain ecosystem as well. Our products include bar, rod, plate, hard rolled, and cold rolled coils. Also, the galvanized and galvannealing and electro galvanized steel coils. Besides the products that are sold in the domestic market, the major exporting market include the one in Southeast Asia and Europe. In order to become a sustainable growth enterprise that can help ourselves and our downstream customers to enhance the ability to overcome challenges from the outside environment, CSC has set the dual core strategies to produce more advanced premium steel products for our customers and to contribute ourselves more to the development of the green industry in Taiwan by the digital transformation, low carbon transformation, and the supply chain transformation as well. 10 action plans has been set up, including to develop and enhance carbon reduction technologies, development the advanced premium steel, introduce of the application technology of AIoT, and to deepen the upgrading work of the steel using industry in Taiwan, etc., have been scheduled to meet this goal. The transformation begins from carbon reduction and is carried out with the help of AI platform and the AIoT tools. The value is created by the cooperation between members of the whole supply chain. And the supply chain transformation is the way to achieve the goal of making more from steel continuously. The way to develop electric steel for green transportation will be given in the following section. The green transportation begins from the development of advanced premium steels. The definition of advanced premium steel, the so-called APS, is the steel product that has high technology content, high industrial benefit, and high profitability as well. 8 kinds of APS have been developed in our company, including the high-quality forging steel, superior hand-tool steel, high-performance structural steel, steels for green energy system, and the ultra-high strength and toughness steel, advanced alloy steel, cross-generational automotive steels, and the one used in the electric vehicle with the extra high efficiency electric steel. In 2024, the sale volume of APS is around 790,000 tons. The sales ratio of it is about 11.1%. Sales revenue of the APS reached 16.1% last year. The superior property of APS can help to enhance competitiveness of and profitability of our downstream customers and help them to withstand better to the impact of environmental fluctuation. This is some examples that the APS used in the industry and for construction of the skyscrapers, bridges, container ships, and bodies and model for the transportation vehicle, etc. There are many series of electric steel produced by China Steel, including the low iron loss type, low iron loss at high frequency, high flex density, extra high flex density, high strength, and annealing type high strength electric steel. The electric steel was coated the electric steel is coated with the cell bonding film on the, besides the traditional production of the electric steel that we can provide to our customer, we also can provide the innovational cell bonding electric steel to our customers recently. The electric steel coil was coated with the cell bonding film on the surface of it on our production line. The bonding strength of the core made by SBES can reach a level higher than 5 megapascal after they are cooling on the customer's production line. Better performance can be achieved by the application of SBES-made traction motor used in the electrical vehicles. Due to the use of SBES, a smoother magnetic flux path and lower iron loss of the motor core can be fabricated. Moreover, a more compact and rigid iron core will be got after heating and cooling process of the SBES as compared to the one that made by traditional riveted iron core. As a result, a high efficiency, better performance, and lower vibration of the motor in operation can be achieved with the use of SBES accordingly. Besides the outstanding material that we can supply to our customer, we also provide total solution of the application technologies that are necessary for our customer to fabricate motor with the SBES. Solutions include simulation and analysis technology to choose the suitable ES grade for the motor, and technology of automatic laminates, stacking and alignment, technology of heating and cooling inside and outside the punching mold for cooling of the SB core, and the integration technology for the physical property, magnetic property and thermal property of the motor were also combined in our study to help our customers to use the SBES for their motor development. There are some of the application technologies that we developed to help our customers to produce motor cores with SBES. We can give process parameters to support them for staking, heating, and pressurizing of the core during the process for their motor making. And we can also help our customer to design and optimize the industrial heating coil to get a better temperature distribution inside the SB core during the heating process and the cooling process. In order to help our customer to get a better process for their mass production, several demonstration pilot lines and equipment were also developed in our lab to show them the way how to make the motor coil with the SBES continuous in their production line. To accelerate the development of technologies needed for the application of SBES, the Electrical Motor Technology Research Center, which is called the EMTRC, was built in National Cheng University and helped to carry out simulation, analysis, and optimization works for the SB core design. Some fundamental studies for the induction heating and punching mode technologies were also carried out in some of the local universities and institutes. We also set up joint research labs with our customers, such as the Delta Company, TECO, Fukuda, and Foxconn Company in Taiwan. To carry out the energy, to carry out the early vendor involvement studies with them to get a better design for their model by using our superiors SBES. These are some works that we did with EMTRC to build the technology on the simulation and analysis of motor performance for different kind of coil designs using different types of ES grade produced by CSC. With the technology build, we also take care of the proof of concept of the new design. This is an example that we did to prove our concept of new motor core design with our SBES for EV and compare the performance to the one that used in Nissan Leaf tracing motor. The on-board testing showed that the motor made by SBES has a better maximum motor efficiency, large area and speed range of high efficiency. The peak torque of the SB motor is also higher than the traction motor used in Nissan Leaf. The technology had been applied to our customers and helped them to develop the traction motor for powertrain of domestically produced electric logistics vehicle and the next generation e-bus successfully. Besides the application of SBES on the traction model of the domestic EV and e-bus market, we also help our customers to expand their overseas market with the innovational SBES made by China Steel. This is one of the examples that we help T company in Taiwan to expand their overseas market in India. The 350 kilowatt tracing motor with a maximum efficiency of 98% for e-bus have been developed and produced by using China Steel's SBES successfully through the operation of joint research labs between China Steel and T company located in Taiwan. T company had put them into mass production and got an order to supply 5,000 units of powertrain for e-bus and 50,000 units of powertrain for light commercial vehicles to one of the India EV manufacturer. CSU will continue to help T company to produce SB core for traction motor in India and develop new traction motor for other EV and e-bus application in the future. This is another example that we work together with EMTRC to help one of the local motor manufacturer company, the so-called F company, to expand their market in Vietnam. With the superior SBES supplied by CSC, simulation work from EMTRC, fabrication work from F company, and the integration work by the V company in Vietnam, a joint research is carried out in recent days to develop the 150 kilowatt rare earth free EV model recently. The opportunity for app company to get another new market investment seems able to become true in the future by this kind of cooperation in 4 companies. In conclusions, China Steel has developed a series of high-grade, extra high-grade, and extra thin gauge self-founding ES, including the low iron loss, high flux, extra high flux, high strength, and Indian type high strength, etc. type that can help and meet the requirement of high performance and high efficiency motor application used for green transportation. Besides the support of materials, China Steel also develops the necessary application technologies for the customers and run the joint researches through JLR and ERC set up in academy and research institutions to help them to shorten the time to mass production. Many success examples have been achieved through the operation of this EVI model. We will continue to help our downstream customers to enhance their technology and green competitiveness to apply this steel and give more contribution together for the green transportation in the future. With this slide, I thank you for your kind attention.
Well, thank you very much for the very interesting and exciting development. And so the motor by itself is the heart of the EV. So we really appreciate and for you to provide this information. And from the audience, do we have a question? Yes.
This is Nian San from my dear group from mainland China. Thank you for the nice presentation. I have a question regarding the curing process of the core. You use inductive heating, which is pretty hard to control. Have you considered using conventional furnace for curing the magnetic core?
Yes, we can use both the induction heater or the traditional furnace for the curing process of the SPES motor core. They are already carried out in our downstream customer.
Thank you.
Any other question? Okay, thank you very much for your presentation. Okay, and then, yes, in the closing, I would let you
first. Thank you very much. After our plenary talk, I think every audience should feel very harvestful. We will strive our best to fulfill the requirement of every audience. Thank you very much. This is Stephen Xijie Fang from National Cheng University. Thank you.
I'd just like to thank all of our speakers. I think it was really great sample of different pieces of industry that cover the breadth of some of the things we do in IAS, from data centers to steel mills in our metals committee, to the people using the steel in our machines committee, to battery storage, and all of the other technologies along the way. So I want to thank the local organizers for putting on such a great show for some of the fantastic work that's happening here in Taiwan, and really showcasing it to the rest of us that aren't from Taiwan. It was really great to see from my perspective.
Well, thank you very much. And all the presentation, this is the very rare opportunity here to have all the experts and cover a very important area within the industry application societies. Yes, in Taiwan, we see a lot of industry. They play a very important role in the world economics and the manufacturing. So we move to here and then listen to the exciting news and also the exciting development. So this is, we really appreciate all the speakers come here and then provide their in-depth knowledge and in-depth information to share with the audience. So with that, I'm the one between you and the lunch. Okay.
So with lunch, there's lunch behind you. You can all see food when you turn around. But I want to do a plug for the Women in Engineering session, which is happening, I think, on second floor. So there's also lunch being provided at the Women in Engineering session too, so you don't have to grab lunch here, I don't think. So at 11:20. So there's, I encourage as many of you who can, if anybody that's interested, there's a great panel being set up for the Women in Engineering session, and there's lunch there too. Thank you.
Yeah, the title for their presentation is The Better Me. So that we really encourage you. Okay, we don't have a gender discrimination, then everybody is welcome to attend the Women Engineering panel discussion over there. It's in the the room and down in the second floor. So, and for those of you who would like to have a lunch here, then the lunch is basically behind the stage here in the back of the room. So you're more than welcome to grab some. With that concludes our morning session. And thank you again for your attention and for your participation. Thank you.